Hello, I'm Mike Dudley, Virginia Asphalt Association, here to talk to you about Chapter 4 in the Asphalt Plant Level 1 course, where we're going to cover sampling asphalt mixtures. Some of the learning objectives for this presentation will be describing the primary roles and responsibilities of both VDOT and the contractor personnel. We're going to identify the different types of sampling that's required to be done by the Asphalt Plant Level 1 technician, and we're going to also describe how asphalt samples are taken and reduced down to testing size. The different titles or different certifications available here for the asphalt technicians are: for the contractor, you have an Asphalt Plant Level 1 technician. That's the minimum certification you have available, which is required for taking a sample and quartering it down. The Asphalt Plant Level 2 technician is the one that will do production testing. The asphalt mix design technician is the one who does the mix designs and makes any plant changes to keep the mix within approved specifications. Then you also have a weigh person at your plant, and he's the guy who's running your plant. He's printing out the weigh tickets and filling out the TL102s for the total day production and providing that to VDOT. For VDOT, you have the district materials engineer. He's basically responsible to oversee the whole QA program. Then you have a QA monitor, which is the individual that will be going back and forth, getting samples, observing things being done at the plant, doing things like that. And you have the inspector. He's going to be the individual for VDOT that's going to be making sure that the tonnages are correct, the temperatures are correct, and the quantities, daily quantities, add up correctly. Plant Level 1 role and responsibilities. What's the responsibilities of an Asphalt Plant Level 1 technician? As we stated earlier, he's going to pull a representative sample for acceptance and quality control testing. He's going to also pull samples for production and process control monitoring, which will be the VDOT side of it. He's going to reduce these samples down by quartering. This is the typical way to do it. And then he's going to monitor and record mixed temperatures of each truck. He needs to monitor, every time we take a sample, it's important we take a temperature. There is a place on all the forms for the temperature of the load when the sample was taken. For the VDOT side, we're going to be working with some verification, sampling, and testing, and the independent assurance samples. What is VDOT's responsibility? Well, first off, the class you're in now, they're going to provide the exams and issue the credential, if you pass the exam, when you complete this class. So VDOT provides all the exams and exam questions. They're going to inspect your plants. This has to be done a minimum once a year. There's actually paperwork that's maintained in the district office that has to track that these inspections was done a minimum of once a year. If you have a plant that has trouble from time to time, you can do it more than once a year, but it is required to be done at least once. They can do periodic unannounced inspections. These inspections can be inspecting anything from your stockpiles, how you manage them, how you keep them from getting any segregation happening or contamination happening. They can inspect your equipment. They want to make sure all your lab equipment and all is kept right. Your weighing operations, whether it be at the plant, make sure your scales are stayed within calibration and certification. They're going to watch you when you take your sample. They're going to watch the producer technician take a sample, make sure that's done right. They may just be in your lab while you're running a test, and they're going to watch you observe that test to make sure what you're doing right. Then they're going to also review the records, which is in the MITS and PLAD system, and see that is kept up to date and kept current. VDOT's also going to keep a diary of their plant visits. They're required to do that, and I would also add in, even though we're talking about VDOT responsibilities, I recommend the contractor do the same. You want to just keep a daily record of what's going on each day. They're going to make sure that the acceptances of the product that's being sold to VDOT, purchased by VDOT, is within specifications. They're going to provide these samples based on the contractor's test results, and they can provide VDOT with the IA test results for the comparisons. They're also required to offer you a referee system as a producer. Why would you need a referee system? As you probably heard in an earlier presentation, or we'll be hearing in the future, that this could be utilized if the contractor's data test results don't line up with the producer's data. But you can either producer or VDOT can request a referee system, and this is where it requires samples to be taken out of the field in the area that is questionable, whether or not it's right or wrong or within spec, and those samples have to be sent off to a third party and evaluated to determine payment. They perform the IA and the VST on the contractor's QC test results, and as we stated earlier, they observe testing or sampling. Sampling asphalt mixtures are two primary responsibilities of the asphalt plant level 1 technician. One is to sample the mix. Once that's been done, you're going to reduce the mixture down for testing size. Getting the representative sample. Representative sample is a small portion of material that has the same physical and volumetric properties as the group from which it was taken. When I say group, what am I talking about? And I say if you take a sample off the top of a loaded truck, as long as you've done it properly, the results you get from testing that sample should be the same as the whole truck. And in the same concept, since that truck was randomly picked for the tonnage you're going to sample, it would also represent a larger volume of mixture that's been placed in the field, placed on a job site. As we talked about when to take this sample, we'll talk about a stratified random sample. That determines when you're going to take your sample. It's basically divides your sublot up into 5,000 tons, basically, and it's a stratified random number that breaks it up into equal portions or locations, however you want to call it. But when we say equal portions, it's more like equal tonnages that have been selected solely by chance. You're not going to always sample at ton 25 or at ton 250. It's by randomization within that predetermined division, which is 500 tons, as to what frequency you're going to be taking this. There are two types of samples. One for production control, which is basically your quality control and acceptance testing. These are performed by the contractor. This is basically your furnace burn, your gradation, and the testing that they're going to be responsible for. When it comes to the monitor sample, this is basically your VST for VDOT or your independent assurance for VDOT. This is when VDOT will either take a split sample, but it may not be a split, it may be a standalone sample, but they're just testing their materials to make sure that the data they're receiving lines up within D2S of the material data being reported by the producer or the contractor. The size sample you'll need for these tests is depending on what you're going to be doing. Or if you're going to be doing a furnace burn and gradation, you probably get by with 10 pounds, no problem. But if you're going to do a volumetric sample, you're going to need at least 25 pounds or more. So getting a representative sample, the Road and Bridge Specifications Section 200 and 211 basically state that the asphalt plant level 1 certification is required to take a sample. You can have a higher certification, plant 2 or mix design, but you have to have a minimum of an asphalt plant level 1 certification to take a sample. We're going to take the sample using VTM 48, which is a Virginia test method. It's a sampling procedure that will explain how the sample is obtained. We'll be discussing that more in a minute. And as far as the frequency and intervals in which we determine that we take our samples, that is determined in the Manual of Instructions, Chapter 5. Section 200.06b states that the asphalt plant level 1 technician is required to take a sample. Section 211.12 states that a certified plant level 1 technician or a certified plant level 2 technician shall sample the material at the plant. Sampling reminders. Samples must be pulled at a rate of at least every 500 tons of any mix type, whether it be your surface mix, your intermediate mix, your A mix, your D mix. It's based on whichever mix type you're running. Now, if you're running a higher production days, you can get approval from VDOT to go up to 1,000 tons so that you're pulling a few less samples based on higher production rates, and you can then take a sample every 1,000 tons. This has to be approved by the engineer, and the engineer has to approve your randomization process. I know Mitts and Plaids offer a randomization calculation. You may use a calculator, you may use an Excel spreadsheet, but whatever you decided to use, you have to have that randomization process approved by the engineer being VDOT. So sampling from the plant, let's talk about Virginia Test Method 48. Basically, it follows AASHTO R97, but with a few modifications. We'll talk about those modifications in this process as we go forward. The purpose of the sampling is take a small amount of material that represents the whole. The representative sample test results are a picture of the entire truckload of materials we stated earlier, or possibly even more than just the truckload, but it has to be done and it has to be chosen in a ratified time. So here we have getting ready to look at a video of loading a truck. Here the truck driver is applying a release agent to the bed of the truck. He applies this release agent so that the asphalt mix doesn't stick in the bed of his truck. You have to be careful not to apply too much, but it does work and you have to make sure the product you're using is from the on the VDOT approved list. Now he's pulling underneath the silo. Once he gets up underneath the silo here, his truck will be loaded. Here comes the load. Bed of his truck's being filled. For this particular video, he's running a surface mix, and therefore he's actually loading it in one dump. We do recommend, especially for coarser mixes like a base mix or an IM mix, you would do multiple dumps in the bed of the truck to help prevent segregation. Once he's received his full load, he'll pull around to the sample rack where we would begin to take our sample. Now let's continue with VTM 48. Samples are obtained from the back of the truck. In most incidents, there are cases where you might want to use a mini stockpile to take a sample. As far as the producer goes, that would only be for QC purposes. It wouldn't be for assurance acceptance or anything like that. I have seen stockpiles done. I don't know if any of you have had a chance to work with the Virginia Transportation Research Council. When they take a sample, they take a much larger sample than you can obtain from the bed of a truck. So they will drop 4 or 5 tons in the bed of a truck, pull over next to the rat pile, dump it out, have the loader strike it off, just like what you would do with a pile of aggregate. And then they're able to sample straight down from that pile to give them, since they're getting much larger samples, 20 plus boxes, it gives them a better representative sample. The contractor level 1 technician is responsible for obtaining the samples. And as we stated already, the samples must be, the sample times must be determined through a stratified random approach that's been approved by the engineer. Basically, to take the sample, you use the square point of the shovel. You strike off a minimum of 6 inches of the very top of the load. As I stated during that video, that this load was loaded in one drop, so it has a peak. You're striking off that top 6 inches so that you get what we call a level platform. To do this, you're going to move the shovel back and forth horizontally to remove the material, and that will leave that level platform from which you will take your sample. It's important when you take the sample that you don't dig too straight down. You sort of want to dig at a slight angle, and I'm going to show you in a video what I'm talking about at the angle we want you to use when you're acquiring the sample. Here the technician he's leveling off the top of the load. You can see he's using, as we discussed, he's taking his shovel, moving it back and forth, leveling the material out. But notice when he fills that shovel up, he's throwing it to the left or the right. He doesn't want that coarse aggregate to fall right back where he's getting ready to take a sample. So now he's got a nice level platform. He's just going to wipe his shovel off, clean it off. And now he's getting ready to take his furnace burn and gradation sample. One scoop right in the middle. That's going to net him approximately 10 pounds. And now he's got his gradation sample. Now, when it comes to volumetric testing, which would mean we're going to run the gyratory, you need to run 3 gyratory pills and a rice, and a lot of people run an extra furnace just to validate the results at this time. You're going to need a much larger sample. All right, in order to get a larger sample, you need to use the same shovel, but you need to sample from multiple locations within that platform that we just saw, and your minimum sample size needs to be up to 25 pounds. So here's a short video showing how to do that. So here the technician is. Previously he took the shovel full in the middle. Notice now he's on the left side. He's taking the shovel full here. But and it's a little space in between the previous shovel full. He's making sure he's not letting where he's taking his sample segregate back in that area. And he's taking them from different locations across the top of this platform. This is to ensure he gets a good representative sample to do his volumetric testing. What he's going to do now, you'll see the technician. He's going to reach back in the truck and get his thermometer. As we mentioned earlier, you always take the temperature of the load when you take a sample. Like we said before, don't forget about the temperature. You always want to record the temperature of every load. And throughout the production during the day, you want to always test the first load of mix, the fifth load of mix, and then you're going to test your mix temperature hourly after that, as long as everything stays within temperatures. So what do I do with all this asphalt I've got now? Well, first I got to reduce it down to a size I can test. This is done by quartering. Basically, in order to do a quartering sample, I have to remix the material as best I can not to segregate it once I've brought it into my laboratory. Once I've done the remixing portion by roll the material over a few times, I'm then going to quarter it out into uniform quadrants, both divided into 4 quarters to give me uniform quadrants. So as we stated, first mix the material thoroughly by turning the entire sample over a minimum 4 times. You want to create a conical pile. You want to do this as you roll the material up and over. You'll see a video on this in just a minute. And you continually deposit, as you create this conical pile, the material back on top of your sample. You want to carefully flatten the conical pile out as best you can on the top, pushing it down. And you want to maintain approximately 4 to 8 times the diameter of your conical pile compared to the thickness. You want to visually inspect the material before you go any further. You want to, as a trained technician, you want to look at your sample and make sure it doesn't appear to be segregated. It wants to be uniform. Then we're going to divide the material into 4 equal quadrants and combine diagonally opposite quadrants to make a sample. Here the technician has got his sample, he's put it on a splitting table, and as we discussed earlier, he's remixing the material by pulling the material from the outside edges and placing it in the middle of the conical pile. Now he's flattening it out so he can do his quartering. First he's going to divide it into half, separating it far enough that it won't come back together, and now he's going to separate it into even quarters. From here, he'll start removing 1 quarter at a time. He's putting this first quarter in a pan, possibly for testing or for saving. Notice he moved one edge over out of the way so he can take the other quarter. Those now are together in this pan. Now, typically you'll find this happens quite a lot. The other half of material is still too big to do any testing. So the technician here is going to remix one more time. He's remixing, bringing the material up to the conical pile and going to flatten it out. And then he's going to do another splitting, dividing it in half. And then quartering equal quarters. Now, again, he's doing this to obtain the proper specimen size, sample size that he can do testing on. So he's going to combine a couple of these quarters. See, he moves this to the side so he can get the quarter that's diagonally opposite of it. Puts this inside the same bowl. Don't know, this could very well be a furnace burn gradation, or it could be, you know, depends on what test he's preparing to obtain here. The other 2 halves can be combined now into the other half of the sample. One thing I want to point out, you need to use extra caution when working with base mixes or intermediate mixes. These mixes have a larger gradation band, so because of the larger gradation band, there's more opportunity for segregation. And here's a video showing you what I'm talking about. As you can see, just looking at this mix, it's a base mix, the large aggregate it's got in it. You can tell he's, again, mixing his material up, setting it on top of the pile, creating that conical pile. But it's important here before he begins to divide it, he's leveling it off, he wants to look at it and make sure it's homogeneous. Make sure he doesn't have any segregation, because these mixes are much easier to segregate, and this is where you can really affect your test results if you don't take time to do a good job of mixing your sample up before you start quartering it. Now that he's quartered it, he's going to take opposite quarters. Here we are, moving the other half over. Taking the diagonally cornered, opposite diagonal corner, put it in a pan. Notice this sample appears to be much larger than the surface mix we showed in the previous video. That's because it is. You need a little bit more material when you're dealing with larger aggregate sizes, and the sample requirement test sizes are bigger. Here he is. He's going to do his base just like he done his surface. Going to mix it up one more time. Rolling it on the top, leveling it off, looking at it, make sure it's nice and uniform, okay? Splitting it in half, then in quarters. Move in a quarter of the material, sliding this quarter over, getting the opposite quarter, diagonally opposite quarter, and adding it to the same sample. Again, the purpose of this process is to reduce your sample down to the proper testing size. I hope you noticed that we did not use any scooping during any of this process as he attained his sample size. Everything was done by quartering. Now he's taking the other two quarters that have been combined and he's putting them in a weigh scoop here. Probably a good chance this is going to be a furnace burn and a gradation sample. So now that we've talked about quartering in detail, let's talk about some other options available to us. You can also use a sample splitter. The first one you see here is a Gilson splitter. That's typically used very commonly in aggregate splitting, but you can also use it for mix splitting. The other taller device here on the screen, that's actually, I think it's called the Quarter Master. You can put multiple sample bags of material in this Quarter Master. You flip this lever and it divides it into fours right off the bat, not even into half. It puts it into 4 quarters right off the bat. With all that, these are other options that you can use in addition to quartering. Now I know the process, but what are the requirements? Let's talk a little bit about what we do here with our samples. According to the Manual of Instructions, acceptance testing is performed by the contractor. Acceptance testing starts out with the gradation in the asphalt content. As we've discussed and saw videos on, this sampling is always taken from the center of the truckload, and when you're doing just an asphalt content and gradation, you need a minimum of 10 pounds. But remember, if you're going to split this with VDOT, you would need to obtain a 20-pound sample, do the quartering or some sort of splitting method so that you each net a 10-pound sample. When we take these samples, it's important we measure the temperatures. We want to measure when we take our sample, but we also want to measure the first load, the fifth load, and then every hour there afterwards. As long as all these temperatures are within acceptance range, we're good. If any temperature happens to fall outside the acceptance range, on the same load of material, we need to take 3 additional readings. Once we've taken the 3 additional readings, we'll average all 4 to determine if the load meets temperature requirements or if it actually has to be rejected and sent to the wrap pile. Process control is performed by the contractor. This is basically your volumetric test, which is now also called the superpave test. As we stated earlier, sampling is done from various locations in the truck. It's always on that top platform, even though it says various locations. I do mean randomly on that top platform, not on the side of your load or anything like that. A minimum size sample would be 25 pounds. You probably even want more than that if you're going to run 3 gyratory pills. Sample VST and IA samples. Samples are obtained by the producer certified plant level 1, level 2, or mixed design technician. These samples are obtained in the presence of VDOT. VDOT's going to watch you take their samples almost always. Sampling is done at a random frequency. Don't forget, these randomizations have to be approved by the engineer. And when it comes to a VDOT VST sample or independent assurance sample, these samples will be tested in the VDOT laboratory by VDOT personnel. Sampling for the VST and IA are done at the same time. They don't have to be done at the same time, but they can be done. First sample is obtained in the first lot of material, which is basically up to 4,000 tons, and preferably within the first sublot of material. Sublots are divided into 500-ton quadrants, so we would take our first sample randomly, stratified, randomly picked within that first 500 tons. The VDOT representative directs the producer certified technician when to obtain the sample, and then basically this sample is kept for comparison and volumetric results compared to the contractor's test results. I'm going to talk a little bit more about the VST sample. Again, if I'm doing a VST sample, I need a minimum of 50 pounds. Why would I need 50 pounds? I'm going to split this with the producer or with VDOT. So I need 25 pounds minimum for VDOT and 25 pounds minimum for the producer. So when you're taking this much sample from one truckload, that you may end up having to strike off that platform on top of your load twice, just to make sure you get a good non-segregated sample that you can then split with VDOT. Samples shall be packed and marked per section 203 of the VDOT specification, and the VDOT representative is required to complete a TL10 indicating that this is actually a volumetric test sample. An IA on the contractor's QC test results. First samples obtained again within the first 500-ton sublot. The VDOT representative directs the producer certified technician when to obtain the sample, and these samples are used for comparison for asphalt content and gradation as compared to the contractor's test results that they're submitting from their materials. IA is a minimum sample size. Again, if I'm going to split with VDOT, I know my minimum sample size was 10 pounds. So if I'm going to split this with VDOT, I need a minimum of 20 pounds. So that once I've split it in half, and this can also be done by quartering, taking the opposite quarters and stopping and not splitting again, basically I would have 10 pounds for each producer's lab, both the producer and the VDOT lab. When an IA sample is retrieved and the QC sample has been obtained in the same sublot, this IA sample data may be used for the next sublot. What I'm saying here is if I've already ran my QC sample at like ton 120, and VDOT come up on the plant site and says at ton 310, which is still within that 500-ton sublot, that they want me to obtain another sample, it's no problem, I'll obtain another sample. And VDOT allows us for the sample results from that split sample to count toward the second sublot of material or the next 500-ton sublot of material as far as acceptance purposes. With that, I'll say there's some knowledge check questions on this chapter, and I want you to review all of them. Make sure you feel comfortable with them before you take your exam. If you have any questions, you can talk to your moderator. Thank you and have a great day.